Welcome to the Golden Mathematician YouTube channel, where mathematics is simplified and broken down to the tiniest pieces just so you can understand and develop love for mathematics. Get ready to unlock the world of numbers, equations and problem solving. Whether you are a math lover, a student or someone who's just curious and wants to know more about the beauty of mathematics, I assure you that you are in the right place. Don't forget to subscribe and hit the notification bell so you never miss out on new videos. So without further ado, let's explore, learn and conquer mathematics. In today's video, we are going to be learning about a major concept in mathematics, which is calculus. But because of how wide the topic calculus is, we are going to be focusing on a sub or a topic in calculus, which is functions. Now you need to know that functions in calculus or maths in general is totally different from what you originally understand by the word function. So what then is this function that we are talking about? A function is a mathematical relationship between two or more variables such that a change in one variable will lead to a change in the other variable. So what does that mean? It means that, okay, let's assume we have two different variables, x and y. And let's say x and y are related in such a way that for every value of x, there's going to be a corresponding value of y. That is, the moment we get, let's say, a particular value of x, when we impute it into the formula for y, or when we impute it into the formula, we are going to get a different value of y. The moment our x changes, our y is also going to change. That way we can say, oh, fine, we found a function. We now have a function. Y is going to be called a function of x, which mathematically would be written as y is equal to f of x. F of x, which is pronounced as f of x, simply means that y is a function of x. So I'm going to share with you some examples of functions. We have y is equal to 2x plus 1, y is equal to 3x squared minus 2x plus 7. We also have y is equal to sine x. By the time we get deeper and deeper into today's video, you see that we have different kind of functions. So don't be surprised when I say y is equal to sine x. So also remember, I told you that a function is a mathematical relationship between two or more variables such that a change in one variable is going to lead or cause a change in the other variable. So let's pick our first example where we have y is equal to 2x plus 1. Okay, let's just say our y is 5, right? And our x is 2. Because by simple substitution, you can see that if we put 2 in y is equal to 2x plus 1, we would have 2x would be 4 and 4 plus 1 is going to be 5. So our y is 5 and our x is 2. I hope that is fine. So now what I mean by y is a function of x is that the moment we change the value of x from 2 to another number, okay, let's say 3, the value of our y will change and can no longer be 5. So let's try it out. We said our x should be 3, right? Okay, so since y is equal to 2x plus 1 and our new x is 3, therefore y is now going to be equal to 6 plus 1, which is equal to 7. I hope it's clear. So let's look at the second example. Y is equal to 3x squared minus 2x plus 7. So let's say, okay, let's just pick a random number. Let's say, okay, let's say our x is 1. So therefore our y would be equal to 3 minus 2 plus 7, which is 8, right? Our x is 1 and we got our value for y as 8. But the moment we change our x from 1 to another number, okay, let's say 2, you notice that our value for y is also going to change. So let's try it out and see what our value for y is going to be. By the time we change our value of x to be 2, we would have y is equal to 3 times 2 squared minus 2 times 2 plus 7. That is, y is equal to 12 minus 4 plus 7, which is equal to 15. You can see that our value for y changed the moment we change our value for x. So that's just the whole idea of functions. The same thing applies to the third example, y is equal to sine x. If x is equal to 90 degrees, then y would be sine 90 degrees, which is 1. But the moment we change our x from 90 degrees to, let's say, 45 degrees, y would no longer be 1. Then y would now be sine 45, which would be equal to, I think, 0.7071. Yeah. So I just had to illustrate with these examples the meaning of a function. I hope it is clear and understandable. Well, if it is not, feel free to meet me in the comment section, as I will be there awaiting your questions. Moving on, in the function y is equal to f of x, there are clearly two variables, right? And what are they? X and y. Yeah, thank you. Where y is the dependent variable and x is the independent variable. And why is y the dependent variable? Y is the dependent variable because it totally depends on the value of x. Your value of y solely depends on your value of x. Hence, y is the dependent variable and x is the independent variable. So far we've only looked at functions with just one variable, which is like y is equal to f of x, y is equal to f of z, different, just one variables. But the truth is, a function can have more than a variable. For example, we can say z is equal to f of x, y. That is a function containing two entirely different variables, which is x and y. Functions containing just one variable, for example, y is equal to f of x, y is equal to f of a, those kind of functions are called single value functions. While functions like z is equal to f of x, y, a is equal to f of b, c, and z, those kind of functions are called multi-value functions. Remember, in this case, a is going to be our dependent variable, while b, c, and z will be our independent variables. I hope it is clear. Okay, moving on. Yeah, there are different types of functions. I think we have roughly about 7 different type of functions. The first type of function we have is explicit functions. Now, explicit functions are functions that have a variable depending on another. They are just like the normal kind of functions we've been talking about. It's this kind of function where like a change in this y will cause a change in x. Like they solely depend on each other. It's straightforward. Let me put it that way. For example, now the previous example where we said y is equal to 2x plus 1. Our value of y is totally dependent on the value of x. So that's it for explicit function. They are just kind of a straight to the point or straightforward function. Let me put it that way. They are very, very understandable. You get what I'm trying to say. The second type of function we have is called implicit functions. Now, this is the opposite of the first function we had talked about, which is explicit functions. Explicit functions are functions that involves mixed variables, in which one variable cannot be easily expressed in terms of the other. Breaking this English down, it means that this kind of functions involve just like when two chemicals mix. The two variables or the variables in question, they are mixed together, making it difficult for us to express one particular variable in terms of the other variable. It's like they have, let's say, a quadratic equation where most times they are not factorized. Okay, let me give an example of those kind of functions. Let's say z is equal to x squared minus 3xy plus 4y raised to the power 4 is equal to 0. This is an example of explicit function where the variables, they are kind of mixed, making it very, very difficult for a particular variable to be expressed in the term of the other. So that's it. The second type of function, implicit function. We've talked about the first one, explicit functions. Second one, implicit functions. And the third type of function we have is called algebraic functions. Now, these are functions that are expressed in form of polynomials. They are expressed in form of polynomials. For example, a type of algebraic function, we can say y is equal to ax raised to the power of n. Y is equal to ax squared plus bx plus c. That's another example of algebraic functions. These are functions that are expressed in term or in form of polynomials. I believe that's straight to the point. In my further videos, I'm going to expatiate and dive deeper more into these functions one by one. The fourth type of functions we have is called exponential functions. These are the type of functions that are written in a kind of exponential pattern. For example, let me give an example of exponential function. Y is equal to a exponential f of x. That's an example of exponential functions containing exponents, functions with exponent values. So that's the fourth type of functions we have. We also have logarithmic functions. This type of functions are written clearly with logarithm. For example, you can see a function like y is equal to ln f of x. Clearly you know that, oh, this is a logarithmic function. Y is equal to ln so y is equal to log with an exponent down, they write f of x as the power. You know that, oh, this is a logarithmic function. So that is the fifth kind of function we have. We also have the sixth one, which is trigonometric function. This one, I think we have 6 of them. We have the sine function, cosine function, tangent function, cotangent function, cosecant function, and the secant function. So these 4 trigonometric functions. And lastly but not the least, from the top of my head, I don't think there's anyone left I've not mentioned, but we have lastly the inverse trigonometric functions. There are also 6 of them. They're just like the inverse of the trigonometric functions. For example, the sine inverse, let's say sine inverse function, cos inverse function, tan inverse function, cot inverse function, cosec inverse function, and the sec inverse function. So a quick run through: we have the explicit functions, implicit functions, algebraic functions, exponential functions, logarithmic functions, trigonometric functions, and inverse trigonometric functions. So let's look at some questions involving functions. Let's try to solve. Let's see what a math question on function would look like. So our first question is: find f of 2 using the function shown below. And we have f of x is equal to x cubed plus 5x squared minus 9. Well, you may ask, what kind of a question is this? But by the time you get to understand functions more and more, you see that this question is a question that just involves simple substitution. Now look at this. F of x is equal to x cubed plus 5x squared minus 9. Now for you to find f of 2, all that is required of you is to replace the 2, replace the x with 2. Meaning wherever you see x, kindly replace with 2, and that way you're going to get your f of 2. By doing that, we'll get f of 2 is equal to 2 raised to the power of 3 plus 5 brackets 2 raised to the power of 2, or let's say plus 5 brackets 2 close bracket raised to the power of 2 minus 9. So we now have 8 plus 5 open bracket 4 minus 1. After 8 plus 5 open bracket 4 close bracket minus 9, which is going to be equal to 8 plus 20 minus 9, which is equal to 19. So f of 2 is equal to 19. We have another question here. If f of x is equal to 3x squared plus 2x minus 1, find f of x plus 1. Find f of x plus 1. Now this is similar to the first one. Here you are just going to substitute. Yes, very very similar to the first one, meaning wherever you see x, you replace with x plus 1. It's very very simple and direct and straight to the point. But the only difference with this is the former one we solved, we have f of 2, which is a clear digit, but now we are having x plus 1, so it will lead to a quadratic equation. So by substituting, we are going to have f of x plus 1 is equal to 3 open brackets s plus 1 close bracket all squared plus 2 open brackets s plus 1 close bracket minus 1. That is, f of x plus 1 is equal to 3. By the time we expand x plus 1 all squared, we are going to have x squared plus 2x plus 1. So now we have f of x plus 1 is equal to 3 open brackets x squared plus 2x plus 1 close brackets plus 2x plus 2 minus 1. By opening the bracket, we would have f of x plus 1 is equal to 3x squared plus 6x plus 3 plus 2x plus 2 minus 1. And by the time we collect like terms and do all this and that, we are going to get our final answer, which is f of x plus 1 is equal to 3x squared plus 8x plus 4. I hope that is clear. Okay, if it is truly clear, let's solve another example on that same question. Let's find f of 4. Now how are we going to find f of 4? let me leave that to you. Try solving to if f of x is equal to 3x squared plus 2x minus 1. Try solving and tell me your value for f of 4. Okay, let's solve it together. So f of 4 is going to be equal to 3 multiplied by 4 squared plus 2 multiplied by 4 minus 1. 4 squared is equal to 16, and 3 times 16 is going to be equal to 40. It's going to be equal to 48. Then 2 times 4 is going to be equal to 8. So that would be 48 plus 8, which is equal to 56. And here 56 minus 1 is going to be equal to 55. Therefore, f of 4 is going to be equal to 55. So this is just this. We've solved like 3 different questions on functions. But the thing about function question is, the more you dive into it, you kind of begin to see other different questions from different dimensions. But with constant practice and constant learning from my channel and other various math channels, learning from school, learning from uni, learning by yourself, you see that function is not as difficult as it was painted to be. This video is already getting longer than I planned, so for that sake, we're going to end today's video here. But there will be a part 2 where I'm going to continue right from where I stopped. I hope today's class was worth it. I hope you learned a thing or two. Thank you for sticking right to the end of this, and yeah, I hope you meet me on the other side, because I'll be shooting a part 2 of this. So yeah, thanks for watching. I really appreciate it. God bless you.